Hey Honors Calc, so want to revisit this problem as promised. Maybe we could even go over quickly in class rather than you having to watch this video, but so after tinkering with it for a bit, I decided that maybe what would be best was to start by just keeping u simple as sine of x, which then means du would be cos of x dx. Because then the u could perhaps replace all of this business here, so this would end up giving me here a u everywhere I see a sine, and I could replace the cos of x dx with du. This seemed to work out well. The du would replace that, and then it would be all over 1 plus u squared. Well, and maybe now that we see it this way, of course, we would move this u down here. The thing is, this is still, what we end up having is still something that's confusing in terms of our integration, right? We still have more going on than just a simple integration, even after the substitution. So what I'm going to go back and do is call this u1 and du1 and add those u's in there, or ones in there, because what I'm going to do instead now is do a second substitution, where we could make u2 equal what's here in the denominator, which is just 1 plus u1 squared. And so in that case, du2 is going to be 2 times u1 times the derivative of that, which is du1. And then I have to add a oh no, that's it, right? Because the du1 is kind of like I'm integrating with respect to the du1, which is my variable there, so that's why that ends up over here. Okay, so I think we're good. So what then this maybe allows me to do is to rewrite now using the du2. So this 2, well, what I could do is, if I wanted to, we kind of found this to be the easier method, so that means du1 is just going to equal du2 over 2u1, right? So now when I replace all of this in, look, I'll replace this whole thing, 1 plus u1 squared, the denominator, with u2. And then I have u1 still up there, and then I'm replacing du with this, so it's times du2 over 2u1. So it does end up getting it all just in terms of u2. So I have the integral of 1 over u2. Well, I guess this 1 over, I could multiply it by a half to take care of this, and then du2. So now that I only have this u2 and du2, I can then integrate. And when I integrate, this is similar to the one that we had just seen. Well, this 1/2 could even just come on the outside as a constant. So it's 1/2 the integral of 1 over u2 du2 would be the natural log of the absolute value of what's right there, right? Plus c, and I still, obviously the 1/2 has to come down too. Now though, we need to go back and substitute now a couple times, all the way till we get back to what we want to have here initially. So u2 is actually 1 plus u1 squared, so it's 1/2 the natural log of 1 plus u1 squared. But what is u1? Well, I think we made that just sine. So if we're not mistaken, 1 plus sine squared of x plus c, this should be the integral. We can try this out, of course, by saying, okay, let's try taking the derivative to see if our answer is correct. Let me zoom out so you can see all of that a little bit. So, if I have 1/2 the natural log of 1 plus sine squared of x, and I'm going to take the derivative with regard to x of this whole thing. Let's see. Well, the 1/2 could come out, and I could take the derivative, so that's just 1 over 1 plus sine squared of x times the derivative of this, which is this is the same as sine of x squared, so it becomes sine of x to the first power, or sorry, times 2 sine of x, right, bring that down, power rule it, times the derivative of the interior, which is cos of x. So if I multiply the 1/2 times the 2, those cancel, and I'm just left with sine of x cos of x over 1 plus sine squared of x as the derivative. Is that what it was? Yes, it was. Oh my goodness, this was crazy one. Sorry if you were messing with it for a while yesterday, because we hadn't done any together that involved that double substitution. But what you can see is, hopefully it makes somewhat sense. This is just me over here checking my work. Just to clarify, so what I did was I did one substitution, but then saw it was still complex, so I did a second substitution. Got the whole thing in terms of my u2 and du2, which ended up being just 1 over u2 du2, which now makes it nice to integrate, natural log plus c. Then I have to substitute back in what u2 is, which is then gives me it in terms of u1, then substitute the sign back in. And the nice thing was, when I took my integral and derived it, remember, I don't have to worry about the c because it's a constant. It disappears when you take the derivative anyways. That's why I didn't write the plus c. When I derived it, I found that I got precisely what I was integrating in the beginning, so that's a good sign. It confirms that my answer was correct as long as my steps were correct. This was a little funky because I had to do power rule the sine x squared, which gives me 2 sine of x, but then I have to chain rule the interior to get the cos x, which is how I got this here. Maybe we could go over it tomorrow if there's still questions after watching this video. Much love, everybody.